Okay. Well, welcome to what turns out to be the 300th live stream meeting in this series. And this one is a language completeness and consistency meeting, looking at features, trying to make everything perfectly unified and uniform in Wolfram Language. So what we're looking at here, create intermediate directories and overwrite target.
So I think this has become slightly less controversial since the last meeting. So we have some functions that take both a create intermediate directories and an overwrite target uh, uh, options. Um, then we have some that only take an overwrite target. Um, And then there were some weird ones that also only took overwrite target, but
But they meant something different by that.
they meant something different from it. So their current plan is to just pick a sensible default, and if they needed an option, they'll figure something else out in the future.
Okay, but so there's no point in create intermediate directories unless you actually have named a file with a directory in it. Correct?
Correct.
Okay. So these are really orthogonal things. There's like you named a file, but you need to actually be able to dig down to get to that file. And there's a file already there, should you overwrite it. Those
Right.
are completely orthogonal things.
Right. This was really sort of the overwrite target was sort of used as a marker for things that possibly should also take create.
Okay, well, so a copy file, for example, probably should also take a create intermediate directories.
Mm-hmm. Right.
I would think for sure these ones should. Now, why is there an overwrite target in audio capture? Because those have file names in them, do they?
Via a method option. So that they're kind of weird. I mean, this is something we're working on with the, where to store things project. So maybe we don't touch them for now, but you can name a location using a method op.
By the way,
Oh,
that
no,
particular
idle
thing
capture
that just
takes a value
happened,
up level. Okay.
sorry, that particular thing that just happened of taking a long time to load this audio capture thing, that's another issue that should be looked at, because that has to do with the fact that there are giant audio things on this page.
Right. So it must be speech synthesized that you need a method option.
Oh, so this one looks perfectly civilized, and that
Right.
looks like a valid, and I don't see why it shouldn't have create intermediate directories as an option here.
Mm-hmm.
I mean, if create intermediate directories is false and you specify a deeper thing, it's just going to error out. Isn't that correct?
Correct.
Okay, fine. I mean, that sounds highly sensible and just a good way that we picked up that consistency. Well, what the heck is this? Where is the file anyway?
It's in the method option.
That's totally weird. I mean, that's totally weird and crazy.
Yes.
I don't know. I don't understand why speech synthesized doesn't have. I mean, that's just a bonkers place to put it.
Well, I guess the idea is in most cases it picks something sensible automatically.
I know, but it should have a persistence location if that's what it.
Right. Well, I mean, this is part of a. I mean, I don't want to delve into this whole storage location.
Okay, fine.
Right.
But I mean, so we can leave this. We definitely don't want to mess around with this
Right.
right now.
I mean,
I
this
think
is
this is wrong, but
this is not the fixed point, and I'll just leave it at
yeah,
that.
okay, fine. But I mean, to me, speech synthesizer, if it didn't already have an argument structure like that, would be best to have a file argument, just like audio capture does. If we really want, I mean, if audio capture can justify it, so can speech synthesize. Of
Mm-hmm.
put this in a file.
I wonder if it's a matter of it takes an additional argument, right? So
well, it
there's
takes the voice there, but I don't know what. Doesn't even say what the voice. What do the voices look like? Are they strings?
I believe they're strings.
Yeah, well, that's not good, is it? Because Yelda. Okay, we can have Zozia. Wow. Okay. All right. I wonder whether that 16 means it's the 16th person, the 16th clone, or 16 years old, or what? Who knows? Okay. Oh, I see. It's the same person. Who knows? Well, I think there's something wrong with this, and I think that should be separately handled. Is anybody from that team on this meeting?
I don't think so.
Okay. Well, I think they should separately look at that, but I think there's nothing. I think we've clarified what needs to happen for these options.
Mm-hmm.
Okay. Next up, if we could. Now, listen, this one I really want to make sure we get to.
All right. Well, let's do the second one so that.
Okay. So this had a whole zoo of possible linkery, right?
Well, so on Unix, I think we understand, and you can create symbolic links and hard links, and we more or less understand that. On Windows, as it turns out, you can't actually create symbolic links unless you're administrator, so
Okay.
it would fail most of the time. So it's not just enough that be on Windows 10. You need to enable this so-called developer mode in order to be able to create symbolic links without being administrator.
Okay, but do we have a proposal for the function that's operation that creates links at all? So, I mean, it would be just like we have copy file, it would be something like link file. Is that right?
Right.
Well, so what Windows supports, I mean, it does support these things called hard links and junctions. And but they have weird sorts of restrictions relative to what one might expect symlinks to support.
All right, but the fundamental concept is link file from file 1 to file 2. And then maybe there's an argument that says the type of link.
Well, remember, links can link directories too.
Fine. Okay.
Right.
Well, file
yes,
1, directory 1, whatever it is.
Well, I mean, you called it link file.
Yeah, I'm not sure it should be a link file. I think it should be more like create link.
Well, what does copy file do with directories?
Nothing. It only copies files.
I don't think that's correct. I think you can copy a directory.
I'm deeply skeptical of that statement you just made.
Is there a separate thing called copy directory?
Yep.
Does that have a dash? I see. Okay. I hate something like file system link because I think that's a I mean, helpfully, ln is called make links. Interestingly, they talk about it as file in their summary.
Right. So a hard link, they both have to be files. You can't hard link a directory. A symbolic link, being just a pointer, can point to anything. In fact, it doesn't even have to point to anything that exists.
Yeah, it can point to nothing.
So that's sort of a fundamental difference between hard links and symbolic links.
Well, in a sense, link file is dealing with the common case, and to say footnote, you can link directories doesn't seem horrendous to me.
Well, you can link directories some of the time.
Right, exactly. Which is why link file might be a good name for it.
Maybe.
That's what I would propose. Link file, file 1, file 2, default as a hard link. By the way, we also presumably need unlink, don't we?
No, because you delete links using delete.
Delete file.
Yeah.
Okay. But so file 2 in this picture doesn't exist, right?
Correct.
So there's an overwrite target option that's needed here. Or isn't there? If file 2 exists, you want to blow it away and say, actually, I want file 2 to be a link to file 1.
Yeah, you need the option.
Right. I mean, I don't think that should default to true, but
No, it should default to false.
By the way, there's another oddity here, which is that one might want to specify a relative path name, and normally when we think of relative path names in Wolfram language, we think of them relative to current directory, but for links, it's relative to where the link is.
Oh, is it? Is that what ln does? Really?
I think so. I believe that's true. I would need to double check, but I believe that is in fact true.
That seems very weird to me.
Well, I mean,
Copy file could do that too, but it doesn't. Copy file
frankly,
just takes it relative to the whole path.
I mean, and the short answer is there is this oddity, so that basically whenever I create a symbolic link, I always cd into the directory that creates it, so I won't get confused, because otherwise I get it wrong. So there is an oddity in here. I just can't tell you exactly what the spec is.
Okay. Well, I would argue that whatever it does, copy file should be doing the same thing. And since copy file doesn't do some weird relative thing, I would think this shouldn't either.
Well, I mean, in the case of copy file, though, it's, I mean, the issue here is that you're actually embedding into the link, a relative path from where the link is. And you may want to be very precise about how that gets written. I mean,
oh gosh, yes, I see what you're saying.
You don't want it. You don't want to compute an absolute path. That's actually what you don't want.
Because the link, when you move files around, wants to still stay somehow linked.
Yes.
Oh, that's a can of worms. That is an unbelievable can of worms.
Right. So the way ln works is that file 2 is resolved because that's where you're creating the link, and then file 1 is copied literally into the result, so that if you without any canonicalization, so if it's a hard link, then that relative path must correctly get you to the source, and if it's a symbolic link, then it will just point to wherever the first argument points to relative to file 2, or I guess the directory containing file 2 to be precise.
Carl on the live stream is asking, it's not clear whether delete file will delete the link or the file. No, it will delete. If you say delete the name of file 1, then it will delete the link. If you say delete file 2, then it will delete the file it's pointing to. In other words, if you use the name of...
No.
If it is a link, it will delete whatever you specify. If it's a link, it just delete the file which is a link. If it's a hard link, it will...
I know. But what we're saying is it's linking file 1 to file 2, right? So file 2 is the destination.
Really, it's linking file 2 to file 1, right?
Okay, what I mean is I type in the name of file 1. It's called, fish.
Mm-hmm.
And that will go to, but what it will really pick up when I say, open fish, if fish is hard linked to foul, then it will actually open foul, right?
Correct.
So if I say delete file of fish, it will delete the link that links fish to foul. It won't go and reach through the link and delete foul.
Oh, yes, it does not dereference the link. Yes, and
Right.
some operations do. There's a
You're saying delete file doesn't dereference the link, but for example, open does dereference the link.
Yeah.
Now, presumably, if we have this, we also have to have things like saying resolve the link, right? How would you resolve the link?
You basically take the link and you find the location, the full path to the file.
I know, but how do you do that? What is it?
Well, and you might not want to resolve the link directly. You might want to resolve a path that has one or more links in the path. That's a useful thing to want to do.
I think absolute file name will do that. So do
It
like
does
absolute
that, yeah.
file name of /tmp. Right, so that resolved that symbolic link to what it actually points to.
Okay. Okay. Well, so what's okay? So I mean, to me, all right. What are the questions that remain here?
Right. So I guess, so if we're defaulting to hard links, and if it is in fact the case that you can create hard links without being an administrator on Windows, then I think this is fine. You know, symbolic would be, you know, that would be more problematic on Windows.
Yeah, well, so then it probably doesn't work on Windows. I mean, I don't, symbolic links are a creature of, a modern Unix. Even when I started using Unix, they didn't have symbolic links. Those were added. God
Right.
knows when, probably in 1980 or something. But
right, I can certainly tell you that by the early 90s they had symbolic links.
Oh, for sure, yes. I think they were added sometime in the around 1980.
Okay.
All right, can we go on? I mean, I think this is a reasonable direction. I think we should try to implement this and see where it goes.
The only other question is, do we want to have a mode for creating, shortcuts, like, in the Finder or in the...
That would be lovely. That would be lovely. I would love that. I didn't know that was possible for a program to do. I thought you had to go into the Finder itself to do it.
I mean, I think that's just creating a special file. I don't know exactly, don't remember the details because it's been a long time since.
Well, putting it on the shelf and the Finder and things. Go ahead.
I mean, it's certainly, I can speak on Windows. It's certainly possible to create them. Most things don't know what to do with them.
Except the Finder.
I think you and Stephen may be talking about different things, because I just heard Stephen talking about putting on the shelf, which is that's a different concept.
I don't know what the shelf is.
Well, so for example, I have these things here.
Yeah.
Right?
Oh. Yeah.
Shortcuts of some kind on some shelf.
Yeah, I don't know how those are implemented. Right, there's the if you drag something across file systems, or if you right click, you get the option to create a shortcut or copy. So that's
a shortcut basically a symbolic link, or is it something different?
It's something different. It's
all right, let's go research that.
Although symlinks do work fine in the Finder.
That's true.
Yeah,
guys, let's go find out more facts about this and come back to this.
Well, just so you know, I mean, I use symlinks for stuff that's linked to from my doc, and it works just fine. So, yeah.
Okay, can we tackle something that I know we need, which is this edge queue question? Okay.
I don't think Ian Hodgnicky or I are required for anything else here.
You are not, so feel free to prepare for the.
Great.
Fine.
Thank you all.
Okay.
Bye.
See ya.
Bye.
Okay. The issue here is that, let's see, what we've got. Charles, can you describe what the issue is? The issue is you're adding a tag to the edge, to an edge specification, right?
Not really. The point is, edge queue, before we actually add a tag, were also used to figure out if two vertex are adjacent, right? So now, since we have tag, is no longer the case for tag edge. So the question is, do we want a new function? It have nothing per se to do with edge queue, right? Because edge queue, we define it like, the second argument is an edge.
Well, I understand. So this is basically graph adjacent queue.
Or vertex adjacent. We have adjacency list already. We have a set of those adjacency functions, maybe just one new one.
So vertex, what would it be called?
Should be normally something close to adjacent vertex queue or something like that.
Well, I believe it should be adjacent vertices queue, but
Yep, this is.
Okay, but then the form of that would be graph and then vertex 1, vertex 2. Is that right?
Yep.
Or list.
Well, should it be a list or should it be? And what would happen if we just called it adjacent queue? Is that obviously wrong?
There's also adjacent matrix.
No, we have adjacency matrix. We have adjacent list. Right. So if another part of the system doesn't need it, it's fine. So.
I think given that we called this adjacency, we don't want to talk about vertices. We just call it adjacent queue. Okay, let me raise a different issue. So somebody was complaining about the fact that you used to be able to take an edge and just say last of it to get the second, vertex on the edge, right? Is that correct?
Yes, from the last tweet meeting, yep, review, yes.
Okay, so can we go over that, please, for a minute?
Okay.
What is that you can take? What is the construct that you can take last of to get currently before tagging? What is that construct?
well, isn't it part pound comma 2?
Of what?
So essentially, you want the list of vertices of an edge, right? So there are several ways to do it. You can take.
I want to know what was the thing that people were complaining would stop working because of tagging? Could you answer that question, please?
So
so that is edge queue as far as I know. So that was a complaint that now edge queue will not work for tag edge. It's not stopping working. It will still work.
How do you? Okay, a tagged edge. What is it? What do we call this? What is the thing?
It's undirected edge with a third argument.
Right? Okay, that's the problem. That's the problem. That undirected edge now has a third argument, right?
Yes.
And does directed edge also have a third argument?
Yes.
Okay, so let's not beat around the bush. That's the problem. The problem is you can no longer go in and ask for undirected edge, part 2 of undirected edge, and expect to get the destination, right?
Yes, you can.
How?
Part two
is still the same.
Part 2 is still the destination. We've just added a third argument, which is tag.
The complaint was last. The person was not using part 2. He was using last.
Okay, well that's all hackery. I mean, okay, so how would I get nice and cleanly?
So do vertex list of try that vertex list of that undirected edge.
So vertex list is normally applied to a graph, but can be applied to an individual edge.
Yes. Actually, prior to version 12.1, if you put a list around it, it works because we support even rules will work. So you can put a list of rules, a list of.
I mean, the question is, it seems to me a pretty common thing to want to get the beginning of a directed edge. And saying first to vertex list seems kind of icky.
Adding, we also kind of run away from that. Adding a new function just for that also seems to be too much.
I agree. I mean, there's a sub-value for directed edge, like start and end.
No.
What's that?
No, we don't have, no.
I know we don't have it, but we could have it. I don't know whether I like that. Okay, let's throw this into, okay, let's talk about hypergraphs. Okay. So Max here has been working on hypergraphs. Is Max here?
Yes.
Okay. So we were starting to make a list. I don't know whether you want to impress people with some random hypergraph demo. But basically, in a hyperedge, okay, hyperedge is a list of vertices with a symmetry specification, right?
Right.
Okay, Charles, you understand that, right?
Somehow, what symmetry mean?
Okay. In an undirected edge, you can as well go from 6 to 5 as from 5 to 6.
Right.
Okay. In a directed edge, you can't. In a hyperedge, the question is, when you come into the hyperedge from vertex A, do you go to, can you go to, which vertices do you go to?
Wait a second, that's a different issue.
Okay.
That's an issue of where you can go is different from the issue of which arrangements of hyperedge are identified with each other.
Fair enough. Charles, how would you make the same distinction for ordinary graphs or not?
Well, I think here we are trying to assign a property to the subset of the edge. As far as I know, you can have a directed hyperedge or undirected hyperedge.
No, wait a second. No, you're not addressing the issue. So what Max just said is there are two different meanings. One is, you're routing into an edge, out of an edge, etc., right? The second case is the identification in the graph for graph isomorphism, okay, of which edge is equivalent to which other edge. Right? For graph isomorphism, a graph that has, two nodes, A and B, and directed edges that go from A to B, both go from A to B, is a different graph than one where one edge goes from A to B and the other goes from B to A, right?
Right.
But if those were undirected edges, those two are the same graph.
Yes.
Okay. So similarly, for a hypergraph, you can have symmetries at the hyperedges of the hyperedges.
What I mean is that that's one way to see it, and that shouldn't probably the case the way we add it to the system.
What?
Because I said that's one way to see it, right?
Yeah. What's
but it's
another way
not
to-
necessarily the way to actually add it in the system or extend the current functionality.
Why?
Because those symmetry property are, you're adding an additional information to the edge, which is not necessary. Right? The edge just purely describes the topology or the connectivity without any additional property.
But it does have it's like a directed versus an undirected edge.
But then there is no ambiguity when you try to resolve it. It's the context where you try to resolve it, like when you decide to do isomorphism. Right?
No, wait a second. I don't understand what you're saying. There's two issues. One is routing through the network, okay? And there, one can have an arbitrary routing through a hyperedge, right? You come into one node of the hyperedge. Which nodes do you go out from? In the case of an ordinary edge, a binary edge, if it's a directed hyperedge and you're going down the one-way street the wrong way, you don't go. You see what I'm saying?
Yes.
right? So in a hypergraph, you can come in one side and there could be any given, there is essentially a little graph that defines inside the hyperedge, there is a graph that defines where you can go, right? Isn't that correct, Max?
I think so.
But my point is that no, you are specializing your hypergraph or your hyperedge. So that's my point.
Yes, but just like in an ordinary graph, you specialize into a directed graph and an undirected graph. What's your point?
Well, my suggestion was just that we shouldn't probably do that in our design, but leave that freedom or that.
No, that can't work. The functions will depend on whether it's an ordered or directed hypergraph or not, just like they do for a graph, right? It means something different. It's got to be different. It's not useful to have a hypergraph that doesn't allow those possibilities. Just like it wouldn't be useful to say, oh, well, because we don't feel like it, we're not going to put directed graphs into the system. That would be silly, right?
No, I don't refuse that. But what I mean is that we are making a specialization up front. I mean,
what specialization are we making? We're
symmetry.
saying, no. Okay. Look, the general case, I suspect, is that there is a graph that represents the relationship between the nodes in a hyperedge. Okay, I suspect that's the most general way to think about it. And that graph has some automorphism group. And that is the symmetry associated with that hyperedge. Do you think that's correct? So for example, if it was the complete graph, then that would mean that this is a completely undirected hyperedge. If it was a graph that is just sort of a daisy chain from one vertex to another in the hyperedge, then that is a different kind of thing. But I think that the graph inside the hyperedge is what defines, I claim, both connectivity and symmetry. Max, what do you think?
That very much can be the case. I'm not entirely sure, but it looks like it.
Okay. Anybody else? Jose, anybody else here who has an opinion about this?
Well, so, I'm not sufficiently expert in hypergraphs to know, exactly what's being talked about here, but is that second argument really a general symmetry? I mean, can you put an arbitrary permutation?
I think we're agreeing it's not a symmetry, that the symmetry is the wrong idea. That second argument really there is essentially that's itself a graph, and that graph operates on these on those vertices to determine the structure, to determine what's allowed. And we probably would want certain things like hyperedge, ABC, maybe we have a thing undirected here or something like that.
So let me ask it naively. If it's a graph, so why do we need A and B?
Because this is a single edge. I see what you're saying. Well, because
I mean,
there are many, look, because no, those are okay. You're saying every hypergraph, you could think about a hypergraph as being, by the way, somebody is not on mute and is making a noise here. You can think of a hypergraph as being a bunch of nodes where I can suppose you can imagine that there's a graph at every edge of the graph. Let's see. This is slightly confusing. So,
So-
at every, go ahead.
So for me, a hypergraph, essentially, instead of a binary operation, you have a
Binary operation.
operations, right? And depending on the specialization of the graph now, right, you can do like you suggested, you can have a symmetry. You can say, well, those that set also is a subgraph or is a graph, or it has certain set of property. So that's kind
Well,
of a
you're saying it's a
specialization case.
relation where it could be, if it's a binary relation, there are only two kind of possible relations, namely the undirected and the directed, you know.
Right. But we don't put any restriction on the type of the relations. Right. Maybe later down the road, right, we can specialize it where we have, you know, specific type of relations.
Wait a second. I mean, here, for example, with the tagging, that's effectively defining a type of relation.
No, the tagging is just a naming scheme.
Well, okay, fine. But the relation is that 5, I don't know what you mean by relation here. I mean, 5 goes to 6. And or in the undirected case, 5 and 6, you can go from one to the other.
Right.
Okay. So what's your point? I mean, so in a hypergraph, instead of associating 2 nodes, you're associating n nodes.
Yes. It's a blob of a collection of nodes.
Sure. Right. But the question is, when you do graph operations on that hypergraph, what do you assume about those nodes? For example, let's say that you are, you know, routing information through the hypergraph. Okay. You come into an edge, and in the case of an ordinary graph, you either can go either way on the edge, or you can just go one way on the edge. Here,
Right.
you come in to port 1, and you might go out of port 2 or to port 3, or you might only go from port 1 to port 2, and so on, right?
Yes.
Okay, so I believe that that connectivity is defined by a graph that lives inside the hyperedge. But it's still, in terms of adjacency, every node in the hyperedge is considered adjacent to every other node in the hyperedge.
That's one way to see it, yes.
But one thing one could always do is to puff out each hyperedge into the little graph that represents the connectivity of that hyperedge.
So my point is that we cannot assume that there is a little graph. Is when you think about routing or a certain type of operation that, you know, you look at that, you know, that subset in the hyper edge as a graph. It's appropriate, but some other operation is not.
Well, give me an example. Isomorphism, for example.
Well, isomorphism in principle,
it is still appropriate. Okay,
yeah, it's still appropriate. I mean, to look at it as a graph, but I say maybe in some other case it doesn't have to be that. I mean,
well, let's figure it out. Let's figure it out because the question here is the thing I'm pushing on, right? I don't want to make a mistake as we add this tagging to edges here and cause a bunch of trouble with people, you know, right? I mean,
I'm missing. Sorry, I'm missing the point. I don't see why the tagging will create a problem.
Okay, we just went through this. People thought that edges had 2 arguments.
No, it's one person, Stephen. So we can insist that it's just one person.
I don't think it's just one person. I guarantee there'll be code that breaks as a result of this.
No, it can't. We are introducing it. We are introducing it new in version 12, and you don't generate on undirect tag edge unless you ask it is, you know, a speech. You know, we have a set of constructors. It can. There's no backward incompatibility. Can be.
All right, fine. All right, okay. This is consider it a wake-up call to make sure that we're specifying edges in the correct way. Okay.
Okay.
Because what I want to do is to introduce a hypergraph construct like graph that many graph operations are simply overloaded on. And it seems that most of these graph operations just work.
Yeah, we kind of thought about that at the time, to, what are we going to do with hypergraph, right? So that was close to that, if we want to add it, then we just need time to sit and really work through the design and look at all the possible cases. And
I understand, but I want to
right.
understand this because we are adding, at least in the function repository, we are going to add a bunch of hypergraph stuff, okay? So I want to understand whether the hypergraph that we're adding at least is compatible as best we can see it with all these functions, right? So
Okay.
the concept of the hypergraph is, instead of being a list of directed edge, undirected edge, there'll be a list of hyperedges, right?
Yes.
Okay, so then the question is, of those hyperedges, there is clearly more diversity than just directed versus undirected.
Yes.
Okay, the particular hypergraphs that we happen to be most interested right now in are ordered hypergraphs that have the property that the nodes can be thought of as being in a definite order, 1 to 2 to 3. Does that make sense?
Yes.
Right, so were we to do
But-
routing through that graph, right, then
is that
go ahead.
ordering concept I don't understand? By ordering, do you mean it's a part, or by ordering you mean just is a property of that set in the hyperedge? If it's a property of the set in the hyperedge, I don't see how it will affect the graph.
Max, do you want to say something about this? Is your hypergraph plot thing working well right now?
Well,
Max?
it works the same as before.
So by order, do you mean like in that case, ABC order? Do you mean you have an edge, you have a part A goes to B, B goes to C?
Yes, yes. So a way to represent that in a typical random, okay, this is a nice big one of these ordered hypergraphs, okay? So that's a node, and this here is a hyperedge, this ordered hyperedge thing, okay? So we could also have a cyclic hyperedge where the thing closes on the other side here.
Right.
Okay. So, I mean, the thing that seems to me to make sense is that you specify this thing. Right, so each operation, I mean, I think it's going to be okay. I think that this is the correct form. Now, the second argument here, probably there are a bunch of string names that correspond to the common ways that those nodes can be related. Does that make sense? So like a hypergraph, the hypergraph wrapper can have a second argument, which basically says what the default relation, just like we have directed graph and undirected graph, right? Does that make sense?
Yeah.
Okay, I'm just trying to check that we're not doing anything here with the design of hypergraph that is inconsistent with what we have so far, or where the things we're adding with tagging, for example, are inconsistent with what we're doing with hyperedge.
Okay. My view for hypergraph was essentially that we introduce hyperedge. We have essentially two types: directed hyperedge and undirected hyperedge. One which take one set, the other one which take two sets, right? And we don't introduce a new head hypergraph, and graph just contain the same thing.
Sorry. I lost this. You say we don't introduce a separate hypergraph head.
Yes.
I don't think that's going to work.
It's roughly what we do now. We don't make a distinction between a tree, a path graph,
Well, we are going to make a distinction with a tree. We're going to have an explicit tree wrapper soon.
which is a graph, and we are not building it. That won't work.
It's not a graph. It's a tree.
Okay.
You can turn it into a graph if you want to by saying tree graph.
Right. So, but what I'm saying is that in terms of graph, right, graph have several structures, right? When we did the design, we decided to not introduce a specific head for each of those structures.
No, and that's the right thing. However, I predict that hypergraph is different. That has enough different things. See, I don't think it's going to be the case that we can just go boom, 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 boom down all of these and have it work. Okay? That's why I was trying to inventory which ones does it work for and which ones does it not work for. Like a random graph, I don't think we want a graph distribution that produces hypergraphs. I think that's a separate thing.
Well, I will need some time to think about it. The graph framework is extensive and not that it.
And not what?
I say I need some time to think about.
Yeah, right. Okay, so I
functions.
predict what's going to happen is most graph functions are going to extend to hypergraphs easily, okay? But some will not. I mean, I take your point that we might be able to get away with graph with a hyperedge inside it. I doubt it, though, but we'll see.
And I mean, you can also look at it theoretically. Some people just say hypergraph is just a binary graph. You can always map it back to a graph. It's just a statistical sugar about a certain type of graph.
Well, it's not really, because if you mapped it to a graph, you would end up with different information about the number of edges it has, et cetera, et cetera, et cetera.
Right. But what I mean, that interpretation, we can always apply it, is to interpret some operations, kind of what I meant.
Well, I understand, but we still need a wrapper that has, that correctly counts edges and things. All right.
Sure.
Anyway, Max is going to work on trying to inventory what parts of the graph framework, won't extend to hypergraphs. But I think it's an important point. The hyperedge specification, yeah. All right. I mean, we have to decide whether we're going to have.
There is the other part with the second argument, which is a string, right? It's one of the key feature of graph. It's the auto visualization, the night typesetting when you generate a bunch of undirected edge or directed edge. Having a hyperedge with a string, I'm not sure first how you are going to typeset that. How nice it will be in output.
We don't care about the hyperedge itself. It doesn't matter. The hyperedge itself, I'm not concerned about. I mean, it's the thing built into a hypergraph that I care about.
But some operation return them. I mean, there is that part which is also important, right?
Yes.
And how do they typeset? How do they look? Are they readable? Are they?
Well, I understand that. I understand. So the problem is that just like we have directed edge and undirected edge, right? For hyperedges, we have much more freedom than that. Right?
Yes.
Sorry. It's the first time I find this concept of hyperedge. So I was reading about it while you were talking. It seems what I see that the concept is to have two subsets, one called tail set and the other head set. So among the members of the hyperedge, it's just a matter of deciding which they must be disjoint, which ones belong to the head, which ones belong to the tail. And there is a lot of freedom because you have subsets there.
What you're saying?
There's a special case of it.
What's that?
I mean, it's just a special case of it.
I would think so, yeah. The thing you just described with heads and tails, that's not the only possibility for what happens inside the hyperedge. All right. Okay, fine. Look, I think I'm satisfied that the stuff we're going to do for the function repository is not going to be problematic. And we'll try and inventory what will be involved in yeah. Okay. All right. Okay. We have sort of run out of time, but is there something quick we can do here?
That one, I think, maybe it can be reasonably quick. So, right. So the documentation for inactive claims it inactivates all heads, which is a lie. And, you know,
What does it actually do?
well, it inactivates all heads that don't match the things in. So go to the source ref page, because that'll. So those two notes explain what it actually does.
Whew. So what's the point here? So it doesn't inactivate list, for example.
Yep.
It doesn't inactivate things that are thought to be inert anyway.
Pretty much.
Okay, but so foo is thought to be inert anyway. Is that the point?
Right.
Well, no, it did inactivate
No.
F.
The point is that, right. So in this particular case, the bug report and the very angry complaint I got from Dennis Schneider is that it doesn't inactivate graphics, because graphics is inert. I mean, with list.
Why did he want it to inactivate graphics?
Basically because he wanted to disable the typesetting of it, because he was.
But that's not what inactivate does. Inactivate is about evaluation.
Yes, but since we don't have any formatting rules of for inactive of graphics, then if you have an inactive.
Okay, so fine. So that's a hacky use of that for that purpose. I mean, in this case, right. I mean, that's the opposite way around. That's getting formatting.
Right, because there for you know, a small number of, in particular, of mathy things, which was the intended application domain, we did put in the effort to add formatting for inactive.
Okay, but so foo doesn't mean literally foo.
Right.
It's a certain set of heads.
Right, but yes, there every so we get a bug report. It doesn't inactivate list. It doesn't inactivate graphics. It doesn't,
Okay, what I would do in here, fine, we should add such a note, but we should say that things which do not have evaluation rules associated with them, right, are not inactivated.
I mean, that's not.
It's almost true.
Yeah.
I mean, in reality, there's some internal things that happen even with rule, but things that do not have ordinary evaluation
there are lots of things which don't have evaluation rules that are inactivated.
Like what?
Well, F. F doesn't have evaluation.
Okay,
rules.
so then we have to say built-in functions that don't have evaluation rules. Like, for example, what would happen if I said,
it's really a specific list, right? I mean, right?
What is the, if I say it, doesn't that, oh no, give me some operator, I don't know, circle times or something.
Yes, so.
I see, that inactivates that.
Right. Right, so it's really patterns, list, because we don't want to sort of
I understand.
list structure, and then data containers like
association. It must be among those heads. They're not an
um,
activate association. Why don't we get a list of what we actually don't?
We do have a list. It's right there. Look at the link developer dollar. It's stored in a variable that's user settable. So if you just evaluate that variable.
I don't know why it came in the box, but anyway.
Because you copied also the link, so it created a hyperlink of the result.
How frigging weird.
think you wanted to copy the hyperlink, not the address, but I see.
That wasn't what I intended to do, but I did anyway. What do you mean by symbol rule? What does that mean?
Well, it's documented. So the symbol exclusions are the ones where it skips the head but goes inside and inactivates the contents, and the expression ones are the ones where it skips it.
Well, it's kind of a no entry.
Yeah.
God, I've no idea. This looks like a giant hack tower. I mean, do we think this list is reasonably complete?
We think it's reasonably complete for the purposes for which it was created, and it's user settable. So,
well, it's not. We're not going to document that setting of that. We're simply not. I mean, unless it's some kind of system option. But that's going to blow up code like crazy. All right, listen, I think we need to pick this up at a different time. I mean, this looks kind of horrifying. I think you can at least make a comment for now that certain structural operations, such as list rule and blank, are not inactivated. But keep it vague. Oh my gosh. Like, is regular polygon inactivated? Polygon is inactivated, but regular polygon is not. No, it probably shouldn't be. Oh, I don't know. This looks like a horrible mess. Okay, this is a good LCC topic, but we haven't resolved it here.
Okay. I will point out that $inactivate exclusions is documented.
In the developer context?
Sure.
Okay, let's pick this up another time, okay?
Okay.
All right, see you guys soon.